For a 3-gang meter installation, each with a 60 amps main, the minimum service entrance wire size depends on the conductor material. For copper, you will need either 750 kc mil for a single conductor or 4/0 American wire gauge for 3 conductors. If using aluminum, you'll need 900 kc mil for a single conductor or 2/0 American wire gauge for 3 conductors. Considering the 120-foot run to the rear units, using number 6 American wire gauge copper wire and polyvinyl chloride conduit is potentially sufficient for a 60 amp service. However, several factors must be taken into account. Firstly, you need to calculate the voltage drop over the 120-foot run. Ensure that the voltage of the panels in the rear units does not drop below 10% of the nominal line voltage. If the voltage drop exceeds this limit, a larger wire size will be required to compensate. Secondly, the wire must be buried at a minimum depth of 18 inches underground when using polyvinyl chloride conduit. Thirdly, the polyvinyl chloride conduit must have an inner diameter large enough to accommodate the wire size while also providing sufficient fill space. Since there are no pull boxes planned, the entire length of wire must be pulled through the conduit at the time of installation. Ensure that the wire is properly lubricated to reduce friction and that the conduit has smooth bends to ease the pulling process. Additional considerations include the service disconnect. Verify that the service entrance wires are protected by an appropriate service disconnect, such as a main breaker or fuse switch, rated for the maximum amperage of the installation. This protects the wiring and equipment from overcurrents. Install a separate grounding electrode system at each of the rear units. This must be done in accordance with local electrical codes to ensure proper grounding and safety. Obtain all necessary permits and schedule inspections throughout the installation process. This ensures compliance with local regulations and helps prevent potential safety hazards. While number 6 American wire gauge copper wire is acceptable for the service to the rear units based on the initial information, it is highly advisable to consult with a qualified electrician. A professional can verify the voltage drop calculation, assess other critical factors, and ensure a safe and compliant installation that meets all applicable codes and standards. This professional assessment might include verifying the ampacity of the wire based on the temperature rating of the terminations and the ambient temperature. The ampacity of conductors is covered in the National Electrical Code, specifically in Table 310.16 and other related tables and articles. These tables provide the allowable ampacities of insulated conductors rated up to and including 2000 volts 60 degrees Celsius through 90 degrees Celsius in free air on various raceways. Correction factors apply based on ambient temperature and the number of current carrying conductors in a raceway. Voltage drop is another critical consideration. The National Electrical Code provides guidelines and formulas for calculating voltage drop in branch circuits and feeders. A common recommendation is to limit voltage drop to no more than 3% in branch circuits and no more than 5% in feeders. The formula for voltage drop is voltage drop equals current times resistance. Resistance can be calculated using the wire's resistance per foot found in wire tables. These tables are usually found in the National Electrical Code Chapter 9 Table 8 for alternating current resistance and reactance for 600 volts cables, 3-phase, 75 degrees Celsius, a circumflex 3 single conductors in conduit, or Chapter 9 Table 9, alternating current resistance and reactance for 600 volt cables, 3-phase, 75 degrees Celsius, a circumflex 3 single conductors in underground duct. The grounding electrode system typically consists of a ground rod, ground ring, or connection to a metal water pipe. The size and type of grounding electrode are specified by the National Electrical Code and local codes. Proper grounding ensures that fault currents can safely return to the source, tripping circuit breakers and preventing electrical shock hazards. The conduit fill requirements are specified in the National Electrical Code Chapter 9 Table 1. This table provides the maximum percentage of conduit area that can be occupied by conductors. It varies depending on the number of conductors in the conduit and the type of conduit used. Proper conduit fill ensures that conductors are not overcrowded, which can lead to overheating and insulation damage. The National Electrical Code Articles 300.1 through 300.24 cover the general requirements for wiring methods and materials. These articles provide requirements for the use of approved materials, protection against physical damage, and proper installation techniques. These general requirements ensure that wiring systems are installed safely and reliably. Local codes often have additional requirements or amendments to the National Electrical Code. It is important to consult with local authorities or a qualified electrician to understand the specific requirements in your area. Adhering to local codes ensures compliance and promotes safety. The National Electrical Code Articles 250.1 through 250.198 cover the requirements for grounding and bonding. These articles provide detailed information on grounding electrode systems, equipment grounding, and bonding of metal parts. Proper grounding and bonding are essential for electrical safety and preventing electrical shock hazards. The National Electrical Code Article 310 covers the requirements for conductors for general wiring. This article provides information on conductor types, ampacities, and installation requirements. Understanding these requirements is crucial for selecting the appropriate conductors for your electrical installation. The National Electrical Code Articles 408.1 through 408.74 cover the requirements for switchboards and panel boards. These articles provide information on construction, installation, and overcurrent protection. Proper installation and maintenance of switchboards and panel boards are essential for electrical safety and reliability. Permits are typically required for electrical installations, including service upgrades and new circuits. The permitting process involves submitting plans and specifications to the local authority for review and approval. Inspections are conducted throughout the installation process to ensure compliance with codes and regulations. The frequency and type of inspections vary depending on the scope of the project and local requirements. Electrical installations must comply with the National Electrical Code and local codes. These codes provide detailed requirements for wiring methods, materials, and equipment. Compliance with codes ensures that electrical installations are safe and reliable. Electrical inspections are typically conducted by licensed electrical inspectors. These inspectors are trained to identify potential hazards and ensure compliance with codes and regulations. Passing an electrical inspection is essential for obtaining a certificate of occupancy or energizing the electrical system. Using a licensed electrician offers several benefits, including expertise in electrical codes, proper installation techniques, and safety practices. Licensed electricians are also insured and bonded, providing added protection for homeowners and businesses. Hiring a licensed electrician can help ensure that electrical work is done safely and correctly. Common wiring methods include non-metallic sheath cable, commonly known as Romex, metallic conduit, and cable trays. Each wiring method has its own advantages and disadvantages depending on the application. Selecting the appropriate wiring method is essential for ensuring a safe and reliable electrical installation. Overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to wiring and equipment. Selecting the appropriate overcurrent protection device is crucial for electrical safety. Ground fault circuit interrupters, known as GFCIs, are designed to protect people from electrical shock hazards. These devices detect small imbalances in current and quickly interrupt the flow of electricity, preventing serious injury. GFCIs are required in areas where there is a risk of exposure to moisture, such as bathrooms and kitchens. Arc fault circuit interrupters, known as FCIs, are designed to protect against electrical fires caused by arcing faults. These devices detect abnormal electrical arcs and interrupt the flow of electricity, preventing fires. FCIs are typically required in bedrooms and other living areas. Electrical panels should be properly labeled to identify the circuits they control. This makes it easier to troubleshoot electrical problems and perform maintenance. Clear and accurate labeling is essential for electrical safety. Electrical safety training is important for anyone who works with electricity. Training programs cover topics such as electrical hazards, safe work practices, and personal protective equipment. Proper training can help prevent electrical accidents and injuries. Regular maintenance of electrical systems is essential for ensuring safety and reliability. This includes inspecting wiring, tightening connections, and testing overcurrent protection devices. Proper maintenance can help prevent electrical problems and extend the life of electrical equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform electrical work. Electricity can be dangerous, and improper work can lead to serious injury or death. Hiring a professional ensures that the work is done safely and correctly. Local codes typically dictate the type and size of service entrance conductors. These requirements are based on the calculated load of the building and the ampacity of the conductors. Adhering to local codes ensures that the service entrance is adequate for the building's electrical needs. The neutral conductor carries the unbalanced current from the load back to the source. It is typically sized according to the National Electrical Code Article 220 and must be large enough to handle the maximum unbalanced load. Proper sizing of the neutral conductor is essential for preventing voltage drop and ensuring proper operation of electrical equipment. The equipment grounding conductor provides a path for fault current to return to the source, tripping the overcurrent protection device. It is typically sized according to the National Electrical Code Article 250 and must be large enough to safely carry the maximum fault current. Proper sizing of the equipment grounding conductor is essential for electrical safety. Bonding is the process of connecting metal parts together to create a low impedance path for fault current. This helps to ensure that the overcurrent protection device trips quickly in the event of a fault. Bonding is required for all metal parts that are likely to become energized, such as metal conduits, enclosures, and equipment frames. Surge protection devices, SPDS, are designed to protect electrical equipment from voltage surges caused by lightning or other events. These devices divert the surge current to ground, preventing damage to sensitive electronic equipment. SPDS are recommended for all electrical systems, especially those that serve sensitive electronic equipment. Underground service entrance conductors must be protected from physical damage by being installed in conduit or direct burial cable. The type of protection required depends on the voltage and the location of the conductors. Proper protection of underground service entrance conductors is essential for preventing damage and ensuring a safe and reliable electrical system. Electrical drawings, also known as blueprints, provide a detailed representation of the electrical system. These drawings show the location of wiring, equipment, and other components. Electrical drawings are essential for planning, installing, and maintaining electrical systems. The load calculation is a process of determining the total electrical load of a building. This calculation is used to determine the size of the service entrance conductors, overcurrent protection devices, and other components. An accurate load calculation is essential for ensuring that the electrical system is adequate for the building's needs. The demand factor is a percentage that is applied to the calculated load to account for the fact that not all electrical equipment will be operating at the same time. The demand factor varies depending on the type of building and the type of electrical equipment. Applying the appropriate demand factor is essential for accurately calculating the size of the electrical system. The ambient temperature is the temperature of the air surrounding the electrical equipment. The ambient temperature can affect the ampacity of conductors and the performance of electrical equipment. It is important to consider the ambient temperature when selecting electrical equipment and conductors. The Daerting factor is a percentage that is applied to the ampacity of conductors when they are installed in certain conditions, such as when they are bundled together or when they are exposed to high temperatures. The Daerting factor reduces the ampacity of the conductors to prevent them from overheating. Applying the appropriate Daerting factor is essential for ensuring that conductors are not overloaded. The voltage rating of electrical equipment and conductors is the maximum voltage that they are designed to withstand. It is important to select equipment and conductors with a voltage rating that is appropriate for the voltage of the electrical system. Using equipment and conductors with an inadequate voltage rating can lead to equipment failure and electrical hazards. The short circuit current rating of electrical equipment is the maximum amount of current that it can safely withstand during a short circuit. It is important to select equipment with a short circuit current rating that is high enough to handle the potential fault current in the electrical system. Using equipment with an inadequate short circuit current rating can lead to equipment failure and electrical hazards. The National Electrical Code Article 110 covers the general requirements for electrical installations. This article provides information on topics such as working space around electrical equipment, guarding of live parts, and identification of equipment. Compliance with the National Electrical Code Article 110 is essential for electrical safety. The National Electrical Code Article 210 covers the requirements for branch circuits. This article provides information on topics such as the number of outlets allowed on a circuit, the type of wiring required, and the overcurrent protection required. Compliance with the National Electrical Code Article 210 is essential for electrical safety. The National Electrical Code Article 215 covers the requirements for feeders. This article provides information on topics such as the size of the feeder conductors, the overcurrent protection required, and the grounding requirements. Compliance with the National Electrical Code Article 215 is essential for electrical safety. The National Electrical Code Article 220 covers the requirements for load calculations. This article provides information on how to calculate the load for various types of buildings and electrical equipment. Compliance with the National Electrical Code Article 220 is essential for ensuring that the electrical system is adequate for the building's needs. The National Electrical Code Article 230 covers the requirements for service entrances. This article provides information on topics such as the size of the service entrance conductors, the overcurrent protection required, and the grounding requirements. Compliance with the National Electrical Code Article 230 is essential for electrical safety. The National Electrical Code Article 240 covers the requirements for overcurrent protection. This article provides information on topics such as the types of overcurrent protection devices, the sizing of overcurrent protection devices, and the location of overcurrent protection devices. Compliance with the National Electrical Code Article 240 is essential for electrical safety. The National Electrical Code Article 250 covers the requirements for grounding and bonding. This article provides information on topics such as the types of grounding electrodes, the sizing of grounding conductors, and the bonding of metal parts. Compliance with the National Electrical Code Article 250 is essential for electrical safety. Remember, consulting with a qualified electrician is essential for any electrical work to ensure safety and compliance with local codes.